action potentials. Action potentials are that wave-like motion moving down the cell membrane. Um, we talked briefly about them with muscle contraction, but now we're going to talk about the specifics on how this works. We start with potential. So we have potential across a membrane, meaning there's a difference in charges, or there's a potential for energy to move. With our neuron, we have more sodium outside, or positive ions, than there are inside. So we have some positive potassium ions inside, and we have some positive sodium ions outside. There are more outside. So we say that the inside is negative in relation to the outside when it comes to the charge. If we could hook up a little meter and measure this potential, this difference, we would say that this is a negative 70 millivolts. This is our resting potential. But we're going to talk about, well, what happens when we send signals? How does this change? How does this work? So starting at our axon hillock, and this will travel down the neuron's axon and send a signal to the terminal arborization and the synaptic knobs, which then releases its neurotransmitters to send that signal on further. What we have happening is we get a little bit of a stimulus, and we're constantly being bombarded with stimuli. So there's always this kind of moving of positive ions a little bit, but we need a big enough stimulus. We need a large stimulus that says, okay, we need to send this message further. So what happens is we get a stimulus, and the cell membrane becomes leaky to sodium ions. And this happens regardless of what stimulus we have. But we have a little bit of our sodium ions starting to trickle into the cell. If it's a big enough stimulus, the membrane becomes leaky enough that it changes the potential. We get to what we call our threshold potential, which is negative 55 millivolts. So we've leaked in enough sodium that we say, okay, we're actually going to send this message on. What happens is the sodium gates open, and the sodium comes rushing into the cell, and this creates a dramatic change. So much so that we get more positive ions inside the cell than we have outside. So now we become positive in relationship to the outside. So we have enough that rushes in, we get to kind of this peak potential, which is around positive 30, 35 millivolts. And with this, our sodium channels close. They shut down, they close. No more sodium is going into the cell. This event is when we hit threshold up until about a positive 30, 35. This is called depolarization. So we're depolarizing the cell membrane. Cell is being flooded with sodium internally. Now, while we've hit our threshold, we do have potassium channels happening. They're a little bit slower to take action. They don't happen quite as quickly. But by the time we get to our positive 30, 35, when we hit this mark, then our sodium channels are going to be fully opened, and we're going to have sodium leaving the cell. It gets too crowded, too many positive ions inside the cell. So our potassium here is going to get out. So the potassium channels are open, the sodium channels are closed, and we have potassium leaving the cell. This is going to drop our potential back down toward the negative 70. It's actually going to overcorrect a little bit, but eventually we'll get back to our resting potential. This event with potassium leaving the cell and returning us back to our resting potential is referred to as repolarization. Now we have a crown. We've done our depolarizing, we've done our repolarizing. The cell's back at its potential it likes, but the sodium is inside and the potassium is outside. So we have to get them back to their original spots. This is where our pumps come in. Our pumps then, which require ATP to actively move these ions, are going to shuttle 3 sodiums out and 2 potassiums in. So we're going to restore that balance of more positive ions and the sodiums outside and the potassiums and positive ions inside. So this is our quick overview of our action potentials. And this is kind of a domino effect. The more you have this going, the more gates are going to open, and then you're going to see this event travel down the axon or along with the cell membrane. And the more you do it, the more gates open. So here is our action potential.